Can you hear me well? Yeah, cool.
Yeah,
thank
perfect.
you. Hi, everybody. Today, I want to talk to you about Playlist Detective, a pet project of mine, which is an alternative search for Spotify. Obviously, I'm Alex. I'm a software engineer. You can find me on Twitter at Bobilito. And one thing that I can tell is I love music. More specifically, I love discovering music with playlists. And one thing I can say about Spotify search is that it's great. Here, the talk is not about saying that Spotify search is meh. Actually, it's quite great. It supports, it's quite relevant. You can do typo tolerance. It's quite fast. You can search into multiple things, songs, artists, even playlists. But it's not that great for playlists. You can't really dig into the playlist. You can't really refine by artists that you want to specifically in playlist. So that's why I made this tool, which is called Playlist Detective. And let me try to do the demo. Yes, it works. So this is it. It's a search, as you can see. And for example, if I want a playlist with Umbrella, a song that I love, oops, you can search, add Umbrella. So all the playlists which have Umbrella in their playlist will pop up here. Same thing with the artist. For example, I love Kanye. Of course, Kanye. Boom, I have the, it's searching. And now I have the playlist with Kanye and the song Umbrella from Rihanna. So that's it. Now let's talk a little bit about the implementation. Of course, like any search implementation, you have two parts. The first part is indexing. Here the data will come from Spotify themselves. They have a very great web API. So let's see how it goes. In my case, I want to download playlists, and so I need to get them from Spotify. The problem is that you can't get all the playlists of all Spotify, so you need to have the user ID of a curator that you like the playlist of. So, of course, I've built on my end a list of curators. And once you have the curator, you can get their playlist using this endpoint. Then, once you have the playlist, you need to get the tracks in order to get the songs and the artists. And then, you also need to get more information, such as the number of followers that you will get from the playlist itself. So, it's yet another endpoint. So, all of that is pretty cool, but it's a bit tedious because it's paginated, like you would expect in any web API. And also, there is a rate limit, so you have to handle that, which is a lot of fun. And of course, it's a pet project, so I don't have much time. So I first went for a first iteration, which was a bit quick and dirty. So in this implementation, I have a first script that actually fetches the data from the Spotify web API. And for each of the curators that I've selected, I create a file, a JSON file, yes, very dirty, that I put on the disk. And after that, I read all those files and I push to Algolia. Why do I split those in two? It's because if one part fails, or if you want to do test or redo the indexing, you want to keep something in the between. But it was really sort of run and trash everything kind of mentality at this point. So it's great when you have very few curators. Actually, when I began this project around the beginning, I had only 150 curators, which was fine. I had a couple of hours of indexing time. I did the indexing every few hours. It was fine. But then I find a way to find a lot of curators, well, 10 times more, and it was a mess, really. The idea is that it didn't scale well because I had this fire and forget kind of mentality. I was not smart at all. So I tried to do another iteration with a database in the middle. Woo! High technology. So I use MongoDB, obviously, for simplicity's sake. And the idea is that if I saw that the playlist was not updated, I wouldn't go and fetch the tracks and stuff like that. So it was much, much faster. And actually, if you every time I rerun the indexing or the fetching of the playlist, I have like very, very few playlists that are updated, and actually those are mostly the Spotify playlists. Then you push to Algolia. It's basically the same. Instead of reading files, you read to a MongoDB database. And yeah, so that's it for the indexing part. Searching, so the UI. Obviously, I use Instant.Search.js, well, Instant Search, and more specifically Instant.Search.js because I worked on it. And I use a couple of widgets. And I think that's pretty cool to see that, because you only need a very few widgets to actually build a search UI. That is, I think, pretty cool. The search box, some refinement list, and some infinite hits widget. One thing to say here is because I wanted it to be mobile compliant, so I had to do some sort of drop downs. So I had to do some custom code for that. But that's about it. The rest was templates and stuff like that. And one thing that sets apart actually this search interface is the use of search for facet values. What is search for facet values? It's a feature that lets you do a search into your search. Yeah, actually it lets you search in the list of facets if you have lots of them, which in this case is quite a lot because you have all the artists and all the songs, and you have like lots of artists and lots of songs. So you want to search into them, especially if you are a user that knows specifically that kind of stuff. So yeah, really, if you don't know search for facet values, you should dig into it, and it's built in Instant Search, all the Instant Search. So what now? First, some key learnings. Really, what's interesting is that you can really build a search that is really specific to some kinds of users. There is no one good search. Well, there may be a good search for most of people, but you can also do a search for niche people like that, and that works great for those people. Also, it's fine to start with something that will break eventually, because at least you get to see and validate your proof of concept. And also be ready to improve. Don't be lazy on that. Next, I want to play with custom rankings, because right now I'm using a number of followers. But obviously, if I want to find some sort of niche playlist, I want to do something more smart about that. And for that, I will try to leverage more the data set and do some data analysis on that. Thank you. If you want to go and see Playlist Detective live, you go to playlistdetective.com. You can find it on GitHub. Please find out. Yes, it's not the same name. And you can ping me on Twitter. And also, one more thing. It's mobile first, sort of. It's a PWA, so you can install it on your phone and have it as an app, which is super cool, and it integrates well with Spotify. Thank you very much.
So, is there some question?
Hello, thanks for the presentation. It's really great project. You said that you were doing the indexing automatically every few hours. How do you do that?
So, okay, I used to do that because now it's more of a setup, and I'm a bit cheap, so I don't want to pay for hosting. So I'm doing that on my laptop. I can do that. Well, I would do that every now and then. But before I used Heroku, they have like this sort of cron system, which works fine for a fire and forget kind of script.
Other questions?
I'll be there. I'll be around afterwards.
Yeah, don't worry, we'll be there.
Okay.
So,
you have a question.
Yes. How can you update your MongoDB database with updated content from your curator if he updates his playlists?
Okay, so that's a cool thing. Good question. Actually, each playlist you have an ID, and also you have some sort of revision name. So if the revision name is different from the last one, it has been updated. So I will do the fetching again.
Okay. Thank you.
You're welcome. Thank you.
Thank you very much.